Stellar black hole. A stellar black hole forms when a massive star reaches the end of its life and collapses under its own gravity. The outer layers explode in a supernova while the core compresses into an extremely dense point. It usually contains a few times the mass of our Sun and can strongly affect nearby stars by pulling in gas and dust. Supermassive black hole. A supermassive black hole is found at the center of most large galaxies, including our own Milky Way. It can contain millions or even billions of times the mass of the Sun. Scientists believe it grows over time by merging with other black holes and feeding on surrounding matter, shaping the entire galaxy around it. Intermediate mass black hole. An intermediate mass black hole sits between stellar and supermassive types in terms of size. It is thought to form in dense star clusters where repeated collisions and mergers occur. These black holes are difficult to detect because they do not always produce strong radiation unless actively feeding. Micro black hole. A micro black hole is a hypothetical object with an extremely small mass and size. It would behave very differently from larger black holes and would likely evaporate quickly due to Hawking radiation. These are not yet observed and remain a topic in theoretical physics and high-energy studies. Kerr black hole. A Kerr black hole is a rotating black hole formed from a spinning, collapsing star. Its rotation drags space-time around it, creating a region where motion becomes highly distorted. This type is considered more realistic because most black holes in space are expected to rotate. Charged black hole. A charged black hole, also known as a Reisner-Nordstrom black hole, carries an electric charge in addition to mass. In theory, this charge affects how it interacts with surrounding particles and fields. However, in reality, most black holes quickly neutralize by attracting opposite charges from nearby matter. Accreting black hole. An accreting black hole is actively pulling in surrounding gas, dust, or even entire stars. As this material spirals inward, it forms a hot accretion disk that emits intense radiation, especially in X-rays. This feeding process makes these black holes some of the brightest objects in the universe. Binary black hole. A binary black hole consists of two black holes orbiting each other in a tight system. Over time, they lose energy through gravitational waves and slowly spiral closer together. When they eventually merge, they release enormous amounts of energy in the form of gravitational wave signals that can be detected across the universe.